begin. My name is Dmitry, and I'm doing engineering for Fluence Labs. Thank you for coming for the very first Fluence workshop. Today, at first, I will make a brief overview of Fluence architecture and tell about how it's built. Then I hope we are going to launch a Fluence cluster locally and take a look on what's inside. And finally, we are going to build a simple decentralized application using Fluence cluster as a backend. If you want to participate in the workshop, you either need to have internet or you need to raise your hand right now. He's Alex. He can help you with the USB stick. We have several USB sticks prepared for various operating systems. So let's imagine that I want to build a mobile token wallet application, and I want my users not only to be able to check their balances, but also to make some analytics. For example, to calculate average transaction costs aggregated by day or something like that. How can I do it? Well, I can't, in blockchain world, I cannot simply download all the Ethereum data to the client, to the mobile phone, as well, probably for the obvious reason. To solve this problem, I can try to query one of the intermediate full nodes, but to be honest, I can't trust it. So probably I want to query a bunch of them. But even if this works, those nodes are not really incentivized to run queries and perform complex computations in time. And they don't have any service level agreements. So there could be delays, or there is possibility just not to find enough nodes to make queries in time. But I want my mobile application to run fast, and so to solve this problem, I can do one of the I could deploy my own server, or I may use some third-party server which does this job for me. For example, I can use Infura. This works, and I can access the data this way, but it's not really decentralization. So what I would really like to see is something like this. There is a decentralized network that can read Ethereum blockchain. The client is able to query it and get results in real time. And these results should be publicly verifiable so that the network is trustless. Wonderful. So the question is, could we build such a network, or maybe just already exist? So there is a sort of a trade-off, at least now. There are a few features we would like to have. We would like the decentralization with all its benefits, but we also would like real-time data processing, and ideally we wouldn't like to pay too much for it. Let's see how existing solutions map these features. Let's start with a traditional cloud, like Amazon as an illustration example. It's fast and cheap, but it has a central authority, Amazon, so there's no decentralization. If we take Ethereum, well, it's really secure, but lacks other traits. It's expensive and slow. And even if you consider other faster blockchains, they must process transactions faster, but still not so cheap due to the replication factor. There is another approach, for example, a scaling solution like TrueBit. TrueBit uses a network of solvers and validators. You can submit the data as an input and tell the network to process it. If any node in the network doesn't agree with the result, it can escalate to Ethereum for the dispute. However, TrueBit is kind of oriented towards the batch workload. It's pretty secure and pretty cheap, but not really real time because it requires timeouts before the processing task is considered securely completed. So the question is, could we have all three features in the same system? Honestly, I'm not sure. Maybe one day zero knowledge proofs would come and save us all. But I know one engineering solution. It's a hybrid approach. And that's what we have been working on at Fluence to build a trustless query layer over decentralized data. The idea is to get secure enough results in the real time and have them thoroughly verified later in batch. And if the batch validation finds errors in real-time results, the client might get compensated and bad machines will get fined. In this case, the triangle is filled like this. There is a real-time processing, which is made much more secure by the batch validation. Let's take a look inside the technology. Let's start with the real-time component. Because we don't need absolute security, we could have a really small replication level, probably around 4 to 7 or a little bit more nodes in a cluster. These nodes have a data locality property, which is that all the data required in computations will be stored locally. So nodes don't have to fetch it over the network, and this helps with latencies and with the real time. To combine the nodes, we use a well-known BFT consensus engine named Tendermint. And finally, a WebAssembly virtual machine is used to define and run computations, which allows to reuse lots of already written code, for example, existing databases. Here is one more thing to the story. Real-time cluster stores the history of transactions of state changes it preceded in a decentralized storage named Swarm, which is independent from the cluster itself. Let's go to batch validation now. It has quite different properties compared to the real-time processing. Validators read the history from Swarm, replay it, and search for the incorrect results. There is no data locality and no state kept by the validator over time. This brings an important security benefit. Any node in the network can be a validator, so no cartels can get formed. This is the main idea of Fluence. It's a hybrid approach. So there is a real-time component being watched by the batch validation component. And both of these components are integrated with Ethereum and Swarm ecosystem to serve interactive requests from the client securely. What we are actually going to focus on during the workshop is the real-time interaction between a web browser-based client and a single real-time cluster. So, what's up today? What do we have already coded and ready? We have local clusters combined with Tendermint and using WebAssembly, and the nodes are wrapped with Docker. So Docker is the sole dependency you need to launch the cluster locally. We have prepared an SQL database which is written in Rust, and it's used as a showcase for Fluence platform. So other databases also could be launched. And we have a browser-based JavaScript client library which is used to interact with the cluster from the web browser. So it's enough to feel the flavor of decentralized application development with Fluence right ahead. So let's switch to the workshop part and let's get our hands dirty. We are going to launch a Fluence cluster with an SQL database locally and use it as a backend for a simple to-do application. So if you want to participate, please ensure that you have Docker and NPM installed. I see the Wi-Fi here. Yep, so thanks for helping us with internet.
I do. How do we connect?
And if you have any problems, there is Alex, he stands. So if you have any problems, please raise your hand and he will come and help. He also has several USB sticks with everything that we are going to download on them, so we can even do everything offline.
Maybe we should ask how many people has problems now with Wi-Fi, and then we can move
Wi-Fi
to 1, 2, 3,
Okay.
4. We can move it to another hacker space right now. Yeah.
There is Wi-Fi there.
Yeah.
I think it's quite complicated. Let's vote.
That's what.
You could vote.
Let's continue here, and I will just come to 4 people and help them.
Okay.
Yeah, plus we have USB sticks prepared. We knew that, well, in blockchain world, you no more need Wi-Fi to make things working. That's the new era. So you definitely need Docker installed, and it's better to have NPM installed too, but the Docker is the must. And only bash scripts are provided so far, so Windows is not supported. We'll fix it later. You can join our Gitter. The Fluence team must be there right now, and if you have any questions during the workshop or later, please ask them there. They will help. So I hope some of you may open this repository. We have prepared a repository. It's in Fluence Labs organization named workshop-2018-October. Here I have it opened in the place where Wi-Fi still works. We have the README file here, and it follows the flow of the workshop closely, so you can take a look here. Here are links for distributives, and all the comments you can just copy and paste them, or you can perform the same actions later if it doesn't work right now. So please clone the repo if you can, or download it from USB stick if you can. And we should ensure that we have Docker daemon launched. I have the repository checked out and prepared here. It's my IDE, and is it presentation mode. It's in presentation mode. Yep. I have a terminal window here, and to check that Docker is launched, we can type docker ps and see that it returns no error. So, yep. How the things are going on your side? Does anyone figure it out and have the repository maybe, or Docker maybe? Does anyone trying to participate at all? Without Wi-Fi, it's a tough question probably. Yep, you're trying.
Yeah, I'm already.
Okay, so probably we should continue, right? Okay. So let's launch the cluster. We have a cluster sh script prepared here, and let's launch it. It should take some time to launch. If you don't have the image of the solver node or the container, it will download it, or well, you can take it from the USB stick, and then it forms a Tendermint cluster, and let's yeah, and it runs a cluster of 4 nodes with a Llama SQL databases inside. So what happens while it works? It launches locally 4 Docker containers. It's a minimal BFT consensus cluster. The nodes are combined together with Tendermint, which is also launched, and they find each other. Here we have a LlamaDB database. It's a very primitive SQL implementation written in Rust. The last commits are made about 2 or 3 years ago to this database. We have forked it and added just a few changes to make an adapter for Fluence. This adapter will be lately released as an SDK. And I should mention that it's not a default Fluence application. It's used for demonstration purposes only, and you can run arbitrary code with Fluence. So here in console we see this line. It means that a compiled WebAssembly file has been loaded into the state machine. You can take a look on it. Here we have, it's just a common compiled WebAssembly file. Yep. Just a binary. And here we have 2 messages with a height. These are internals of Tendermint. As the cluster is launched, it needs to make 2 blocks in order to ensure that the initial consensus is reached. So if you see something like this, it means that cluster is ready for interacting with it. Yep, I don't know if anyone sees the same in their laptop.
Let's take a pause and I will check out that everyone has.
Yeah,
okay.
Let's take a little pause. During the pause, I can show you the LlamaDB in the Fluence Labs organization, just to fill the time. So, yep, this branch is 8 commits ahead, so we have added just 8 commits. We have fixed some bugs, and well, yep, but if you take a look on the original repository, it's archived, and well, why have we taken this repository? We willing to ensure that we put we don't put too much requirements on the code to make it possible to launch it on the Fluence. So you really can reuse the old code. And also you can use various programming languages which compile into Rust.
I guess we're good to go.
Wonderful. So let's try out the cluster with the SQL client. Let's open in the Finder the workshop folder. I hope you see it. And here we have a SQL client directory, and we can just double click on the index.html file. Here we have it opened. So here we have on the left 4 blue boxes. These blue boxes each stands for one node of the cluster and shows its internal state. So we have the same height. Here it's the height of the Tendermint chain, the block hash and the application hash. The application hash is the hash of the state of the virtual machine. So this ensures that the operations are performed the same way on the whole cluster, and consensus has been reached. On the right we have the input for queries, the output, and some examples. Before we try examples, let's open the developer console to take a look what happens here. Here we have some logs already output. Okay, let's copy some queries, paste them there, submit. You can see that the queries are sent to the cluster, height is increased for 3 blocks, and you can see some output, so queries have been performed. That will create table query and 2 inserts, so nothing very interesting here. Here we have a bunch of aggregation queries, and they should also work. We have maximum, average, and count here. So here we have the result. As the request fields are not named, so they count from 0, and it's well, yeah, responses are mixed. Probably this is the count, this is the max, and this is an average. You'll see later that requests return a JavaScript promise, so if you want to keep the ordering, you can just do it on the client side. Let's copy and paste the others. We have various queries here, including select, some insertions. It's an explain query, it's also performed. Here we have an error message. It's returned intentionally because one of the statements is wrong, and this just shows how the error message is returned, transferred from inside the virtual machine to the client, and you can see the result here. So, yep, that's how it's working. Does anyone reproduce it? Is it okay? Wonderful. So now let's switch to the front-end application and open the next slide. Yep. So for the front end, we are going to develop the basic decentralized application that everyone is familiar with. It's a to-do application. It will require just a single dependency, JS Fluence client. Current version is 0021, and it will integrate with Fluence backend in just a few lines of code. Yep. So we can keep this open or closed, it doesn't matter. Let's cd into to-do app in the workshop directory and open index.html. Here we have it. Let's open the developer tools and console. Nothing there. That's good. Okay. Zoom in a little. So here we have a simple to-do application. Let's just play with it a little and try to add some tasks. For example, perform a workshop with no Wi-Fi. Ask some questions. So you can see that they are added, and you can move the task from incomplete list to the completed tasks. Yep. But of course, if you refresh the window, they will disappear. So let's fix it. Let's start with the console to feel the flavor of the API of Fluence API from the client side. Here we already have the Fluence. It's bundled and it's imported, so we can use it right now. And at first, to make a connection, we should it suggests me already because I have tried it before. We should create a session. The session wraps interaction between client and the cluster, so you always need a session. It's created by Fluence.create default session. And right now, to create a session, you need to provide a host and a port of any node of a cluster. So let's type localhost here, and one of the ports is 25057. Yep. So we have a session. Wonderful, isn't it? With the session, we have just one operation that's useful, and that's probably enough to do everything. It's invoke. So let's call session.invoke. Invoke takes two arguments. The first one is command, and the second one is arguments. The command is an exposed method of the program which is deployed inside the virtual machine. So in LlamaDB we have only one command. It's named do query, and the second argument it's query. So let's create a table for to-do tasks. Create table to-do list, and to keep it simple, let's add one field named task, and with a type varchar 1 to 8. Yep. Hopefully it's sent to the cluster, and you see that some complex object is returned. Yep. Now we will try to use it. Let's try to add some tasks to the to-do list. We do it the same way. Session invoke, do query, and now let's insert insert. I want to make a mistake. Sorry, I haven't done it right ahead, but insert into to-do list values. Let it be perform the workshop and join the Gitter room. Yep. To get a result of this query, we need to call the result function method result. If you don't do it, then the client won't watch for the results. So yep, it will be fire and forget behavior. Just send the invoke command and don't wait for any reply. The result function returns the common promise, JavaScript promise. So to work with it, we can use then. And let's take a result and yep, and just write it to the console. So let's try it. We have a promise, and here we have a value in the log, and it doesn't seem readable. The reason is that virtual machine uses binary format to interact with the client, and it doesn't know the meaning of the data that's transferred. So if we expect that it will be a string, we need to call a string method on the response. So let's try again. Yep, here we have the error message because I've made it typo. Let's fix it and take a look again. Oh, probably I can click here. Sort. And now.
Excuse me.
Yep.
Could you move the console to the bottom of the screen? From the right to the bottom?
Maybe I can make it wide here and
Okay, thank you.
increase. Is better now?
Yeah.
Yep. Thanks. So we have two rows inserted. Yep, we have processed the response, we have made the query, and probably we will have them in the list. Yep, if you refresh the window, they are loaded. Wonderful. Let's try to add another task, for example, fly the moon. Yep. It's an incomplete task so far. I haven't been to the moon. And now let's refresh. And you can see that it's not saved. So we have prepared the read side, but not the write side for the application. So to fix it, we want to make some corrections for the index.js file. And to do it, you probably need to have npm and a connection to the internet, or you need to have node models prepared from the Alex. So let's cd into to-do list in the console. You see that something is already changed here on my side because I was aware about the internet and I have prepared so that it will work anyway. But what you want to do to have it working on your side, first you want to let me revert it. Press revert. Here in the package.json file, we have only dev dependency of Webpack to build the bundle and combine all the dependencies. So if you call npm install, that's the only thing you're going to install. It's Webpack. Yep. and then you want to npm install JS Fluence client, and the current version is 0.0.21. So let's install it. So we have installed it. And now we need to uncomment some lines in index.js file. So let's open index.js here. Scroll to top. Here we have the import from JS Fluence client to have it in the scope. We create a session just like we did it in the console. Here in the window on load callback, we have some DOM manipulating things which are very simple. Here are the table names, and here we have the add task function. It's bound to the DOM event of clicking the button, and here we have update task list action, and we also want to add a task to Fluence here, so it will be added to the to-do table. Then we have a complete task function here. It's also quite simple. Yep. And here we want to uncomment delete from Fluence that deletes the task from to-do table, and add task to Fluence that adds it to the done table. We can take a look on these functions to see that they are very simple. Just delete from table where task. We do the same invoke as in console, getting the result and calling then and just writing something to the console. So it's pretty simple. And in order to have the updated bundle.js, we need to call npm run build. Let's try it. You should build everything with Webpack, and why bundle.js isn't blue?
You saved the file.
Let's check it. Now I have saved it, and let's run it again. Was what bundle? Oh, yep. Now it's blue. That means it's updated. Now let's return to the application, refresh it, and try to feel the flavor of developing with Fluence. I hope it fits into 128 symbols. And let's yep, the workshop is almost performed, and let's take a look. Okay, I hope someone have joined the Git room. At least I did, so I will even delete it. And let's refresh, and we see that everything is saved. If you open the console of the cluster, you can see that height is increased, hash is changed. You can see that here we have two blocks with the same hash but with a different height. It's due to the process of reaching consensus of Tendermint. So everything's fine. Does anyone reproduce it? Yep. Wonderful. Even without Wi-Fi, we can work.
I think the one in the stick has all this uncommented already, so you don't actually have to do it.
Oh.
Yeah.
Yep.
Ay, ay, ay.
Well, anyway, it works.
Yeah, it
Okay,
works.
so we'll fix it for the next workshop. It's the very first one, so I think it's great. At least that we have USB sticks. So if we have some additional time, let's walk through some more slides. Just a little number. Even though right now Fluence works only locally, we have a tight schedule for the following months. We are going to release SDKs for Rust and for C++ to pick up your code so that it will be possible to make the binary for Fluence. And we are going to prepare various database examples to compile something that's already written and bundle it inside Fluence. And we're even going to launch a test network. It will be an IPFS-like network, so no incentivization, but developers will be able to pin their data and computations to their own machines. And finally, we are going to develop an example of Ethereum substate index to show how Fluence can interact with other decentralized sources of data. So we are going to be a part of ecosystem. There are different potential use cases for Fluence. For example, it makes it easy to build trustless blockchain query layers, something like Etherscan, but decentralized, for example. It also allows to port existing databases into a decentralized environment or build censorship-resistant websites. Yeah. As Fluence is a platform, it can support various applications. So you can think of many other use cases where Fluence fits in Web3 stack. Finally, yeah, if you have participated in the workshop, let's clean up. To stop the cluster, you should call. You can detach from the cluster, and then call cluster sh stop. It will rf the containers, and then let's do rf in the user directory. The Fluence.Fluence folder has been created, so let's remove it as well. And now you should be clean. So that's what we are working on at Fluence. Feel free to check out our repo. We have a lot of Scala here, and also more and more Rust and some TypeScript and JavaScript. So yep. And thanks for your attention today, and I want to especially thank those who participated in the workshop even without Wi-Fi. I think you're great.
Just yes, questions.
What have you implemented in Scala?
We have implemented well, almost everything. So the node is written in Scala. The master process is also written in Scala. We use a lot of external dependencies here. For example, assembly for the virtual machine, for the WebAssembly implementation, and a lot of Java dependencies. But all the business logic is written in Scala. Yep.
Earlier you mentioned the test network, there's no incentivization. So
Yep.
can you talk to a little bit about what incentivization is baked into the protocol here?
Right now, we don't have the ready-to-go token model or economy model. So what we are focusing on right now is the technology. We want to get something stable, and we want at first release a decentralized network, which will be decentralized, which will perform computations in the real time, which will be secure in the scale of a cluster. But at first there will be no batch validation. We are working on it right now, but we will be able to release some kind of test network earlier. So what will you be able to do with it? You'll be able to develop some code for the backend and deploy it and use it from the client side. Yep. But as there is no incentivization, then you will have no guarantees that nodes won't disappear simply. So if you want them not to disappear, then just like in IPFS, if you want your files to be kept and available, you need to pin them. We are going to do something similar for Fluence. So if you want your computations to be launched, you can have a hope that someone will pick this job for you, but it's better to pin it to your machines.
Quick clarification is the token model you're exploring is more towards for developers or the companies that are built on top of this to have tokens so that there's a guarantee of storage? Is that the area you're exploring?
I'm not ready to talk about the token model. We have several models in the development, and yeah, it will be ready to discuss later, probably in several months.
If you want, you can follow our research process. We have research tickets opened in our Fluence main repository. You can follow them, and we're also writing a specification. You can follow it. Also, it reflects our research progress so far.
Yep, on the Fluence repository, really, well, there's no nothing is covered about economy, but we have a lot of internal documents released about the problems which we see, about the decisions which we are making. We have issues which are marked with research, and they look sometimes they look like articles. So, yep, I'm mostly about technology. I don't ready to talk about economy, sorry. But about research and development, just take a look on the repository and feel free to ask questions on Gitter. Any other questions?